Good evening, everyone. Welcome to the Astronomy Fundamentals program of the Naperville Astronomical Association for the month of March in 2021, that is. Thank you for joining us, and we're going to swing right into the program since this is our fundamentals presentation. Our business meetings, as they were, are held at our monthly meetings at the first Tuesday of each month. So I will repeat what I've been saying for months now on these live streaming sessions that we're doing, that if you have questions and you're following us on Facebook tonight, the way to pass your questions along in real time is in the comments section of the Facebook, your Facebook app or your Facebook website page. And we're following those, and any questions you put there that are aimed at the speaker will get passed along to him. If you are following us on the club website, or you just like email better, you can email us. And once again, we're following that inbox, and questions that get posted there will get passed along. So tonight's program, we have as always with our fundamentals program, we have a member speaking. Andy is our current club publications editor, and he's going to be speaking to us tonight about a broad overview of an introduction to astrophotography. So without further ado, let's get Andy on screen and we'll put him in charge of things. There you are. I will stop my sharing and hand it all over to you, Andy.
Thank you. We'll have a pretty fun time with going over, I guess, some of the things that I have been learning as I've been dabbling into the fundamentals. It's basically, I've looked into how I can, do a little bit more with the telescopes. I'm really a visual observer, but sometimes I do like to see what I can gather on the pictures or even to share. So I've kind of looked into the astrophotography side of it, and it really comes down to what your expectations are. And as I'm going to go over an introduction to some of the methods that we have and provide just some options on where to choose from, it will hopefully give you an idea on what you're going to need. Because like we always get, what kind of telescope should I get for astrophotography, or even what kind of telescope should I get? It really always comes down to what you're really wanting to do. Just like we'll tell people that one telescope may not be the best for everything. Some telescopes work better for if you want to look at the moon, or, if you look at some solar scopes can be as small as 40 millimeters, which is not that large of a telescope, but we're looking at something that's very bright that we still even have to dial down. And when you look at taking pictures, astronomical pictures, you're also dealing with the same brightness levels as well as size of objects. So just to give an overview of what to think about, let's compare what you would see when you look and at something with your eye versus when you're taking a picture. And I've got two examples here to show. And one of the examples is just recently the conjunction. The conjunction between Jupiter and Saturn really gives you an idea on how much 100 million miles can make a difference, not to mention size. Even though Jupiter is a larger planet that's closer to us, Saturn with its rings is a pretty good size and does reflect back quite a bit of light. But when I was trying to take a picture of the two, to get Saturn's rings to not look like ravioli or a planet with airs, I had to overexpose Jupiter, where you're basically seeing a blob of light. You look through a telescope with your eye and you would be able to see both the rings of Jupiter as well as, the cloud bands of Jupiter as well as the rings of Saturn in the same eyepiece without having to adjust the focus. Likewise, just over to the side there, there's Jupiter with its cloud bands, and underneath you can see the 4 Galilean moons. One of the cool things about Jupiter is when you're looking at Jupiter visually, you can see the moons dance around Jupiter over a few days. They'll change positions, may create shadows as they cross over. But if you want to image Jupiter and the Galilean moons, you're going to have to do 2 pictures, one with Jupiter in focus and then overexposing to get the moons because they're dimmer. So that's what some of the things that we'll have to think about as we're going to progress into what you're going to want to like to do in astrophotography, what kind of equipment you're going to need, and what your expectation will be coming out of it. Because to give you another idea, to try and get that Jupiter and Saturn to look that bright, I actually had a eyepiece that you can connect a DSLR to, which you normally don't do that type of thing, but this is a special eyepiece that Celestron had. It's called a Ultima Duo, where it has you can attach a T-ring to it. So it gave me a close-up view, which brought the distance between the 2 planets in my DSLR closer. Otherwise, if I showed you a picture without that, you would have as big as the screen you have, and you'd have Jupiter in one upper corner and Saturn, a dot of Saturn in the lower corner. Very hard to see. So there's some processing that may need to be done, which is also something that we'll talk about at a different presentation. But let's talk about that simple question that we get a lot of times. What telescope do I need for astrophotography? And that's really not the question that you should ask, because it's really, do you want to use a telescope, or do you even need to use a telescope? And so as I go through some of these choices you have, you'll be able to have an idea of how those things can go. For example, you'll be able to do some astrophotography with just a fixed mount. Or if you do want to image some dimmer objects, you may need to have a mount that moves to simulate what the sky rotation will be. And that would be a tracking mount. Of course, if you jump all the way to the left side of the screen, you'll see piggyback with telescopes. So you can attach a camera to a telescope, but you can also have it ride on top of one. If it's a tracking mount, you can have just a camera on top, tracking with it to take pictures. And then you have afocal, which is similar to what I was talking about a camera and an eyepiece, but in this case, you have an eyepiece and you can put a camera up as close to that eyepiece lens as possible and just take a picture of what's there. You would need either very steady hands, which I'm never able to do a good picture. I actually always get a picture of the eyepiece lens coming at me. But if you have an adapter to connect that camera to that eyepiece, it will hold it steady and you have a more likely chance of getting a good picture. Of course, it also depends on what you're trying to image, whether you're going to get a good picture. And then there's what is called prime focus, and that's where you're taking the eyepiece away and you're just adding a camera directly attached to a telescope. So the telescope will be like the camera lens. So for those of you that are familiar with cameras where you can switch the lenses out, single lens reflex cameras, and they usually are DSLRs, so they're digital, as well as the regular film ones that may still be around for those that like the art of picture and developing. But that would be where you would attach the camera, and instead of using a camera lens, your telescope is your lens. And I'll talk a little bit about those kind of lenses as we progress. So and then as you think about the prime focus, it's actually also where you may have an astronomical dedicated camera. So it'll just be a camera that's only used for with a telescope to take pictures, astrophotography pictures, and they're usually CCD cameras, so they're just going to have a image collector, and the telescope will be the lens to get the image, and then of course there will be some processing involved as well as laptop to assist you. And you can use a laptop for some of the other options, and I'll go along with that as I talk about each of the options. I'll talk a little bit about some of the basic equipment you'll need to start out with, and then some of the things that you'll need to go as you gain experience. Because when it comes to astrophotography, you're not going to rival the Hubble. Magazine quality shots are going to be something that you can work toward, but it's going to be managing what your expectation is and learning about the process, knowing exactly what you're selecting as your target, and then working toward refining your skills. So let's take a look at some of the technical considerations, some of the things that we'll need to think about. And the main thing that, as I was talking about, is the object to be imaged. Because as I'm going to go through some of these methods, I'm going to show some pictures that have been taken with these imagers or these cameras and give you an idea of what the difference is or what it will look like. And you'll start getting an idea about what is your field of view, what will be in that view. Just like when you've looked into a telescope visually and you see Mars. Depending on this eyepiece that you have, you may have a lot of space around Mars and a little Mars in there for you to look at. Versus if you're looking at the moon in certain phases. I mean, you could look at the full moon, but it's very bright through a telescope. But if you're looking at some of the phases, the moon can fill a lot more of that eyepiece view that you have. And that's because of the angular size. So what we're going to be looking at is, how that object, how you're going to have to consider framing that object and what may be the best tools for it. And then next, you're going to look at what is wide angle. When I mentioned afocal, I was talking about using an eyepiece and a camera that's just above it to capture that image. Prime focus, piggyback. So those are things that you'll see as we go along. Tracking, again, I had mentioned that's where we're going to be the same, we're going to take Earth's rotation into play, so that way when we're going to look at an object and try and expose it for longer than a few seconds, we won't have a star look like a comet or the object get blurry because it's moving. And then some things to consider are focal length, focal ratio, what is fast or slow. And that's going to be the length of either the lens you're using or the telescope you're using. And that focal ratio will be the length divided by the width, and that kind of gives you an idea what may be fast. I may talk about a telescope that has f10, which is a focal ratio of 10, which means the length of the path that the light travels is 10 times as long as the width. Or I can be talking about a shorter focal length telescope that may have a ratio of about f6. And that means that the light can go through quicker. What that means is it may affect the time that you need to expose an object for imaging capture, as well as the gain or the ISO you may be using depending on the imager that you've chose. And then of course you can change some of these things. You're going to look at how can you change your focal length. How do you adjust the exposure time so that way you can get those pictures and then adjust those gains. Get that more photons onto that image receptor. But what does that also do? I will talk about. So, and then after that, you're going to wait for the next presentation that we do when we talk about processing images, so you can go to the next step. So astrophotography, like even astronomy that you've probably already learned, that there's a lot of steps involved. You've can start picking up the constellations visually, then you start learning to find them through a binoculars or a telescope. Well, astrophotography is going to take those steps as well. So that way you can build on each section and get a good foundation going and then move further. And it could be enjoyable. It could be frustrating at times. I could talk as I go through this. I can tell you about all the times I've made a mistake and maybe broke something, but it's a learning process. But let's go back to the field of view for a little bit. I got one image from a book about astrophotography. Two charts here showing asterisms are from the digital SLR astrophotography book by Michael Covington. But what that gives you an idea is when I was talking about those focal lengths and how it will affect what you see in view, up at the top is the Pleiades. And, you know, they're an open cluster known for the Seven Sisters. It's a very nice object to photograph because depending on the exposure, you can see some nebulosity. So you'll see some cloudiness in behind the structure. So it's a really nice object to look at, but it's also over 2 degrees in width, basically. So as you try and do that open cluster of stars, that's about 2 degrees. To give you an idea what 2 degrees would be in the sky, the full moon or the sun is 1/2 degree. So that means 2 degrees would be 4 moons next to each other. And that's the size. So if you were to try and take a picture of the Pleiades, depending on the telescope or lens you were using, you might get all of it or just a couple of stars. If you have a 800 millimeter lens or telescope focal length on a telescope, you might get a little bit of all of it. I have a 6-inch Schmidt-Cassegrain, which is about 150 millimeter. As you can see, that would be somewhere in between the 2000 and the 1250 millimeter range. So I start to only get a couple of bright stars. If I used my 8-inch, I would have about a 2000 millimeter focal length. And then I'd be just getting about 2 good stars and parts of another. Now, what if you wanted to do the Big Dipper? Well, Big Dipper is about 25 degrees. So if you were using a camera lens, that's a 50 millimeter camera lens, you might be able to squeeze almost all the stars in. If you're trying to do a tighter field of view, your telephoto lens of 100 millimeter, if you're doing that 300 millimeter lens, you'll be able to focus in on 1 star. So you would, if you're looking at doing wide angle, as I had mentioned in the technical side, wide angle would be something that could be constellation size or something. You're going to have to make sure you have the correct lens for it. Not to mention and starting to learn about how to focus and how long it's going to take to grab it. And then, of course, if you're taking a picture of the sun, you do have to have a filter on it or you'll burn through a lot of things. Solar filters are nice. Actually, in 2017, before the solar eclipse, is when I really started back into astrophotography. I had a DSLR camera and I started using that to practice. And it kind of worked, except, you know, I put the wrong memory card in. I put the memory card I was using instead of the blank one. So right when it was totality and I was switching to do a little bit of videotaping, I found out my camera card was full. So if you ever looked at the cell phone video my wife was doing of the horizon to show how it looked like a 360-degree sunset, you'll see me standing at my telescope, running to get a new card and then putting it back in. So as I said, I can talk about a lot of things that I've learned while I was doing this. And those are things that you'll probably also experience and have some stories to share as well when you do this. But let's go back to a little bit of the exposure rate. So I was talking about that ISO setting or a gain setting if you're using a CCD or a web camera. And what that is that's to increase the collection of that light, those photons coming toward us, or the signal that we're going to receive. You also, as you try and learn about taking pictures, it's going to be, as I was told, a lot of trial and error. You can learn a little bit about what you need settings wise, roughly from people you've talked to, web forums, things like that. But also books will talk about what you want to kind of get an idea of. But basically, the brighter the object, the less gain you need, the less work you're going to need to do to collect those photons. So that means you would need a lower ISO or a lower gain. So with the sun or the moon, you can do a really low side if you can set it to, for a camera, 100 to 200 ISO. For planets, you're starting to move into the middle range. As you get to the deep sky, clusters, nebulae, or even galaxies, you're starting to pick that gain up. I'm going to show you a picture of one where I was using close to 1600 gain, and you'll see why you don't always want to use that much, or you're going to have to work on processing. And then the focal ratio. When I was talking about that focal length, those f5s, f10s, it's the exposure time. The brighter the object, the quicker you need to expose by, but also depending on the length of your imaging system will determine if you need to increase. So for most of the solar system, it's just a fraction of a second. It could be anywhere from 1/15th of a second to 1/50th of a second, depending on how bright the planets are, as well as looking at what you're going to want to do as you move forward. With the deep sky, you're looking at maybe a minute, and those brighter deep skies, if you're familiar with the Messier calendar, then you can always look at the Messier catalog. Will have brighter deep sky objects. We did have the marathon last month talking about that, and we're approaching that time where we're going to try and look through about 110 of them. But if you're going to image those, you don't need to spend as much time on them because they're pretty bright objects, so you can do them generally in under a minute to get a good view. Once you're getting into galaxies and stuff, you might be going 2 minutes or longer. Of course, if you're doing processing, you can do shorter ones. And those shorter exposures you'll be able to work with by stacking them, which are terms that you'll learn as you go through, and you'll need to know a little bit about it if you're going to use some of the CCD camera setups or the webcam that I'll be talking about. But what you're really wanting to look at is getting an idea of what you're shooting and then finding out what you're going to need to do to take a look at how it is. So with that, let's take a look at those cameras or imagers and some of the associated equipment with them. So I'll give you an idea of what you can actually do I'm trying to move myself a little bit so you can see a little bit more of the picture. This was done with smartphones. You'd think, wow, what can you do with smartphones? And there's really a range of what you can provide to yourself. The first one in the upper left is just me holding up my camera, my smartphone, to try and catch Mars with conjunction with the Pleiades. So as I was talking about the Pleiades, that 2 degree width of open clusters with some of the brighter stars, you can see what looks like the Subaru emblem, or what many people call the Little Dipper, which of course isn't the Little Dipper because our Little Dipper is to the north and it's a lot bigger than that Little Dipper. But you can see Mars is kind of the brighter object toward the lower right. And then moving on, you see a little bit. But that I was trying to throw some exposure, so you're starting to see the camera noise in a lot of background. So that was not exactly too pretty to show, but I mean, it was something nice just to get a wide view. Now with a wide camera lens, I probably would be able to work on exposures and get a little bit better look to it. But you can always do some nice landscapes by adjusting the light level. I was fishing and I took a picture of the moon rising from the trees. So usually when you're taking a picture of the moon, it's very bright, like that picture next to it is, where you see the picture and it's very white light bouncing off. Well, on your smartphone, you can adjust the brightness level. On my Apple phone, I can just touch the picture and you'll see the little light bulb. And if I can move it up or down, it changes it to less bright or more bright. And that will kind of frame what may be brighter against a darker background. And I'm showing that example with the moon pictures that are right next to it. I was trying to get a picture of that rim of that crater. As you can see, it looks like a bright loop here. I was trying to get into it, but because the sun's reflection was coming off, I tried dimming the light, which I was able to now not blind myself with the light reflecting, but also dimmed the crater. So the loop is not as bright, but at least you're able to adjust some of that feature so you can get a cleaner or better picture. And those are some of the ways you can manipulate. Of course, there's an app that you can include that will let you change some of the exposures or even your ISO controls. I believe the iPhone 11 Pro has that already built in native part of it. But if you don't have that, or you don't have that, you can, for iOS, Camera Plus 2 or Program 8 or ProCam 8 in the Apple is a pretty good option for you. For Android, I've noticed, or from what I've heard, is Camera FV5 Lite or Open Camera are pretty good options to choose from. Now, last picture down here is the Orion Nebula with a cell phone camera attached to afocally to the lens. So I'm going to show you what afocal looks like. So with afocal, you're going to have a eyepiece, and either you have your hand steady or you can have an adapter. The adapter I have here is nice because it allows for me to put in different camera sizes, or cell phone sizes, I should say, in there. It lets me control how high or down it goes. So depending on the eyepiece to get it lined up, this platform can rise up or down, and it rises right to left. So I can line up my camera lens onto the eyepiece. So this is how the camera looks. Now, I have an iPhone 11, but I'm actually showing this with the iPhone 7 because I found out my iPhone 11 is pretty heavy. So fortunately, before I upgraded from my 7 to my 11, I kept my 7 just in case I ended up having a use for it. And I guess I do, because as it being a lighter phone and plus only having one lens, I can line it up better and be able to do it. Now, of course, you still have to tap the phone for pictures. So that's something that we have to think about, how you can do that without shaking it up too much. I'm going to, next time I'm out when the clouds break for sometime this spring, I'm going to try using my watch feature to control my camera on my phone and see if I can click it there. But the problem is, if I'm changing some of the brightness levels, I still have to play with the screen. So there's going to be some work involved in it. I'm going to give you some tools if you're looking at adding smartphone photography to what you want to look at, there's some options you'll have for that. We'll talk a little bit about it when I go with the resource side of it, things. Now I'm going to move a little bit from cell phone to DSLR, digital single lens reflex cameras. Those are really nice features to use. They're simple to have and get and kind of work with you. My next stage, though, is to modify mine. Because it has, you can modify them and take away the infrared blocker. It will allow you to get more shots of deep sky objects. But what you can do with a single reflex is, again, here's a picture of Orion. This one, you can see it's a little bit brighter. It's a little clearer than a cell phone one because I was able to use more time. The picture I did earlier was about 3 seconds with the cell phone. This is 15 seconds of exposure time. So I was able to gather more colors. But if you see the trapezium in the middle, the 4 bright stars, they're going to get overexposed the longer you take pictures. So that's where, again, comes back to that dynamic range where I was talking about Jupiter's moons. When you photograph Jupiter, you won't be able to expose the moons. If you expose the moons, then you have overexposure of Jupiter. Same with some celestial objects, where a lot of people go into the processing side where you do a couple of different pictures and you layer them. So that way you can see the different ranges that come out. But let's talk a little bit about ISO. This one was just a regular 800 ISO, so it's a bright object. I didn't have to go that far. This is the Helix Nebula. It was a 30-second exposure, but I had a high ISO gain because I was using shorter exposure times. But see how there's a lot of noise in the background. They're not all stars. There's some purpleness in there, and that is stuff that comes up because of the higher gain. So you kind of have a trade-off on what you want to do to get your image. Of course, this is an unprocessed image. If I have several of these that I can go into the processing stage and try and clean them up and have a nicer one. But what I also want to show you is these are pictures that you're going to have right off your camera without adjusting. So, just with 15 seconds attached to your telescope, you can have a little bit of color in Orion. You can get to see color on the Helix Nebula. If you're out further from the city, you can, with your wide angle lens camera, just with the lens on a tripod, or piggybacking on a telescope, you can get the Milky Way. You can start doing that. Now I'll talk a little bit about that picture because if I had a different lens, I probably would have had a crispier picture of the Milky Way. And of course the moon. This is through a DSLR, so you can see a little nice details along the terminator line. But to get those pictures, what do you need? Well, without a telescope, I mentioned you'd need a mount or a tracking mount. If you're doing things that are longer than a couple of seconds, you're going to need to have something track so you're not going to distort it. You can just use a lens. Now this is an 18 to 55 millimeter telephoto lens. It's usually what you get on a DSLR. If you really want to do wide imaging, you're going to want to buy a different camera lens. You're going to look at maybe getting a 24 millimeter lens, just a prime focal length lens that doesn't telephoto, so it stays at 24 millimeter, or a 50 millimeter lens. And then that'll be able to give you those pictures that you want to take. The reason you want a prime, just 1 millimeter length lens is the components inside there are going to be better quality for imaging, so you're going to have a better view. If I had taken the picture of the Milky Way without, I had my 18 by 55, if I had just a 50 millimeter lens, I would probably be able to have pulled more details because it would have been a better quality image. So when you're looking at where you want to go in the photography side, it's going to start taking a look at what you're going to want to look at equipment wise. Now, when you're trying to take a picture of something without, or even when you use a telescope, you have to find what you're trying to take a picture of. You can use pointers. I have a little Rigel finder. It lets me have a red dot finder so I can line it up. Of course, you have to take some time to line it up and make it work. It's an old one that I had, so I just kind of use it with 3M tape on my Canon to get me lined up. Of course, if I'm piggybacking on a telescope, which I'll show in a little bit, as long as I have it lined up with where the telescope is, I can use the telescope to be my finder scope and then picture through my camera. But whatever it is, you're going to need an adapter to either attach to the mount or attach to the telescope. So you're going to need to make sure you have the equipment to get you onto something solid and steady for pictures. Now, looking at the with the telescope, I'm going to start with the piggyback here. So there's mounts where you can just attach the telescope onto, or the camera onto a telescope, and then you can use the telescope's system to track your images. And then that way, just make sure that the camera is posting. Now, one of the things I found out, though, is you want to make sure that you have everything aligned, usually during daylight when it's easier to align things. So everything is pointing in the right direction. So when you want to take a picture, it's going to show up. So there is a lot of preparation that you need to do before it gets dark. Like moving over to the left-hand side, there is my camera attached to the eyepiece that I was talking about. This is my setup that I used for that conjunction of Saturn, Jupiter. So you can see my yard facing west as I'm waiting for it to just get dark enough right after I rushed home from work. So tried to set everything up, get everything connected, have my laptop ready to try and focus. But when I'm doing that, let's take a look at the tools that I have here for us that you're going to need. To connect the camera to a telescope, you're going to need to have a T-ring, which is this. This attaches to the camera body, and then you'll need to have the extension tubing. For my refractor, I use this reducer flattener. What the reducer actually does is my telescope has a focal length of about 715 millimeters. With the reducer, I get it down to about 560 millimeters. So it gets down to like a 5.6 focal ratio versus the f7 focal ratio. So that means I can make it quicker. I can get a little wider field of view when I'm imaging, and it allows me to get a little bit more of what I'm looking at less maybe ISO or exposure time, because I'm shortening the length that the light has to travel. With the Schmidt-Cassegrain that I have here, you still need a T adapter to replace the eyepiece. I do have a focal reducer because that is a focal length of a focal ratio of 10, and that 8 inches, 2000 millimeter focal length. So with the reducer, I can get it down to about 1200. So remember, the Pleiades, I can get into the middle range. Still not the whole open cluster, but then I probably wouldn't be using this telescope for it. But then I also need extension rings to get everything focused. So you need to know what the focal length is going to be for the camera to come to focus. And then I have an intervalometer, which, remember how I was talking about touching things and having things shake? Well, when you look at it through a telescope, one of the things you always hear say, don't touch it, because you start shaking everything and the image starts bouncing. Well, if you have a camera and you're clicking the camera to take the picture, you're adding movement to the system. I use my laptop a lot to just set the exposure time, my ISO time, ISO or gain, and then I click the button on there to take the image. So that way I'm not touching anything in the imaging side of it. But you can also use this. This is a remote control. This connects to the top of the camera, where you have the flash shoe. You attach that and you program what you want. This also allows me to take exposures past 30 seconds. My Canon camera built in only gives me 30-second exposures. This allows me to do the bulb setting and go up to a couple of minutes if I need to. So it allows me to take those longer pictures so I can gather more of the light. And as long as my telescope is tracking well enough. Now, usually when I'm doing something that's more of tracking, I use a different mount than Nexstar SE system. I do use Equatorial Mount, which equatorial means it's facing the North Star, so it's actually on the tilt to mimic Earth's tilt, so that way it'll just cross over in one direction. It does allow for better tracking, and it's also a sturdier mount, especially for if I want to put a refractor on it, since it's a little longer, so the weight stuff is different. So those are things that we have to think about as we're doing the image setup.
Hey, Andy.
Yes.
Andy, you have a comment on Facebook.
Okay.
Someone asked if you could kind of explain what it means for a focal ratio being faster or slower.
Okay. The focal ratio, fast or slow, means the higher the ratio, the slower it is. The lower the number, the quicker the telescope system is. What a focal ratio is the length of what the light travels through a telescope. In a refractor, it's just straight line through. So this refractor has a 715 millimeter focal length to the eyepiece. So the length that the light takes to get to the focus part of the eye is the focal length. And then the focal ratio is what the objective width is. This is 102 millimeter, so about a 4-inch telescope. So when you divide the 715, the length, the light path through, the width, you get the ratio. So 715 divided by 1, or 714 divided by 102, it's a focal ratio of 7. So focal ratio of 7 is like a medium range. So what it is, I guess, to give you an idea on the focal range, how focal ratio is important. If you're imaging something with a 500 millimeter or f5 focal ratio, it may take you 10 seconds. If you have a f10 focal ratio, it will take you about 40 seconds. There's an actual formula that will let you know how to switch from one focal ratio to another. And it depends on what the objects are. It's focal ratio squared divided by, it's actually in the book I'm going to show you in resources. So to give you a question on what the focal ratio is, fast or slow, it's how long of what is that F number? And if it's a F5, it's considered a faster setup. If it's F10 or more, then it's going to be slow. Now, when you look at camera lenses, for example, if you're buying like a camera lens, you'll see that you can get a 24 millimeter camera lens with the f2.8. That means that's the focal ratio is 2.8. So it's a very quick setup. And that's why when you do camera when you do pictures without the telescope, you may not have to spend as much time gathering it because it's just the lens part. So it's a quicker system to gather those photons. So what the focal ratio is, fast or slow, is just how long it will take for you to consider what type of exposure you're going to use or what type of gain you're using, ISO or gain. And then it's like, if it's closer to a 5, you have a faster setup, so you can use a lower end on those numbers if you're at focal ratios of 10 or above. And that's usually when you're having cadiotopic telescopes like Schmidt-Cassegrains or Maxitoff. Then you might have that longer ratio of f10, f12 versus refractors, which can be lower. And then some telescopes may even have astrographs that are set up for astronomy photos. They'll have like focal ratios under 4 or in the low 4s. And those are specifically set up to take images quicker. They're not going to be very good telescopes for visual observing because the way they're set up for quick imaging, and that's where they have the fast scope. So to go back to it, the lower the F number, the faster this telescope is, and the less you might have to worry about exposure time or ISO or gain for the photographs. So that's how that ratio is. Now, let's talk a little bit about DIY. DIY here is, here's a webcam. As I was doing research, I decided I'm going to finally try and do that webcam build-it-yourself thing that you always read about. So with the regular $20 webcam, I popped off the lens. I found a film canister from back in the film days. Because what it is a film canister is 1 1/4 width and size, which is the size of most eyepieces for telescopes. So what I did is I reattached the webcam without the lens and used this as an adapter for the lens. So that way I could take pictures. Of course, by the time I made the pictures, or by the time I made it, we've been in a very cloudy weather. So I haven't had a chance to practice it. Of course, as I was doing more research, I found out if you don't have a film canister, because how many people still have those in our digital age, that probably would cost more than the webcam, just to find it for nostalgia. There's actually some companies that have those adapters that you can find on a website to sell. But if you are looking at trying to convert one of the webcams you may have, there's some tools that you may want to look at to help with the process. And of course, I'll show you a newer webcam, which are more on the CCD side. But what I've learned is with the webcam, you're going to want to have a Barlow, because why am I talking about webcams? And I guess I should have started with that, is they're actually one of the best tools to use for planetary imaging. The reason being is I'm going to be coming into showing you more pictures of the size of planets in the field of view. And you're going to see how small they are, especially with the DSLR or other imaging choices that you have, which makes it hard for you to even blow it up because of the pixelation. Because if you ever tried to blow up a picture, you start distorting it after it hits a certain, and that can happen with some of the imaging. But web cameras can allow you to help. Of course, this is where it's going to go into more of the processing side of things, so I'm going to stop a little short of that. So this is kind of like a little breaking point as we go into different areas. But the Barlow lens, what it does is it gives you it amplifies the image when you use a Barlow in your telescope. for the eyepiece, what it does is it magnifies that eyepiece's view, in this case by 2 times. You can get Barlow lenses to do 3 times or even up to 5. You want to watch how far you're going with the image, because the bigger the image, the harder it may be for the field of view that you're getting. But a Barlow will allow you to get a bigger image. And what you're wanting to do here, I have a splitter on this side. You can also have a flip meter. This splitter, what it is it has a little camera lens in here, so it splits the light coming through, so one will go up here and it'll go through here. I use this because I could put an eyepiece here and I can put the webcam, or I've done it with my solar system imager back here, so I can kind of see where I'm pointing to, make sure I have it centered, and then I can adjust the focus to see it in here. Now, of course, once you get it focused on your camera, what I then do is I adjust the eyepiece by pulling it up a little bit usually, and then I have it focused on both sides, and I can use the eyepiece to help me find images to do with the webcam. Here what will help with the webcam is a program. It allows you to control your webcam by the gain. So you know how I talked about the ISO with DSLR? Well, you use a gain for CCD camera, where that's gonna control how much of that light grasp is. So you can control this, and what it does is, as it's taking a video, it's also working on processing your image so you can get a better planetary image. So it's a program that I found on Ascendant, AZCENDANT.com. But if you do Handy AVI and do a Google search, it'll take you there. And they have some programs. It's just something that you can consider if you're doing a webcam. I'm hoping soon, but of course we only have a small Mars to try and image as it's getting further and further from us, but I'll have this set up ready for the summer just to see as our big planets come our way again. I'm going to see how this works, so stay tuned. I'll share with the club. All right. Now that I've gotten through some of the multi-purpose, I mean, cell phone we can do with everything. The webcam was kind of our closest dedicated in this case, because I changed it from being a webcam for Zoom to a webcam for astronomy. But I was talking about the Next Image solar system imager. I have that and I've used that. Now I don't have any pictures. I had an accident this summer. I was imaging with my Surface tablet and my SCT, and I had the dew shield on there because it was summertime, so I wanted to keep the dew off my SCT so I could image longer. Whatever I selected in this for the object locator was not the right one, because all of a sudden my telescope was slewing downward, and then it caught the mount because I was using my Equatorial, and it started skipping. So I went to hit the disengage the clutch so that way it would stop the motors before they jumped or anything, and move this tube so that way I wouldn't do any damage. Well, everything was attached. So the camera was attached to by a USB cord. So as I was saving my telescope, my Surface went flying. Needless to say, it didn't survive the landing. So whatever I had on the Surface for imaging is forever gone unless I decide to fix the screen. But I will do more. So like I told you, there's a lot of learning experiences that you can do. When you're in the dark and something's going wrong, got to remember that there's things attached to other stuff. So I do have a laptop now that I just bought that's enough capability for me to take out in the field, but that's also something we have to think about. But back to planetary imagers. So these planetary imagers are kind of like the webcams we have now. They're hopefully using a CCD chip as opposed to a CMOS chip, which gives higher quality, but they're specifically, the size of the chip works with the size of a planet. Because if you try to use a solar system imager for, say, the full moon, you wouldn't get most of the moon in there. You're only going to get, say, if you're on the first phase, even crescent moon, you're only going to get about a half to 2/3 of the crescent moon onto it, because the chip size is made smaller, because the object is, or the expectation is, you want to capture smaller planets. And to give you an idea, Jupiter at its largest is about, I believe, 49 arc seconds. The moon at its fullest is about 30 arc minutes. So that means that's a half a degree. 49 arc seconds is about 8,000th of a degree. So it's 0.008 of a degree. So imagining how many of those will fit. So that's why the sizes, that's why the image chip has to be different. Now, you do have some larger format imagers that are going for the deep sky image. So for the Whirlpool galaxy or something further out, you might want a deep sky imager. Of course, there's also the formats. You can do monochrome or color. Usually with the solar system, you want color, so that way you already have the color of the planets. When you're doing deep sky stuff, you may want to go monochrome because you might want to add filters. So you're grabbing different elements and you're going to put it all together. And of course, that's post-processing side. But when you're getting to the astronomy cameras, you're going to need a telescope because they don't work without them. You can't just use a camera lens. You're going to need to have a tracking mount because you're taking longer exposures. So you're going to need to stay with the object. You'll need a laptop because that's what's going to control your image process. And then you're going to have to go into the post-production part of it to put that image together. Where some of the other choices that we had, like the DSLR, you can basically build yourself up. You can start with a mount or even some of those tracking mounts that they sell now, where you can put a camera on there and it's going to track at the rate of the Earth's rotation, so you can take longer pictures and you can work with where you're going. So you have some options that don't require a lot. Now it's going to come down to what you want. Talking to a friend of mine who we go to whenever he's out, I'll take practice my imaging while he's got his imaging routine. He likes to do it because the galaxies, as you can see in the picture of the galaxy, you can see more of the arm detail, the dust lanes. You see more details in the picture than you will visually observing. You can infer that stuff. You get a great feeling of looking from a dark site at a galaxy and learning to pick out those features, but you'll get a lot more from it. So that's one of the things that imaging was for, and that's probably why I stay with it, because at some point I'll probably want to get a feel for the color of it and something to be able to do it yourself, spent that time out in the dark, hopefully not in the cold, and be able to come back with that image, because you can always see the images anywhere from the website to the magazines we may subscribe to, but sometimes it's an ability to pull those is what really draws you to astrophotography. Finally, what I wanted to do is talk a little bit about some alternatives. They're not necessarily traditional astrophotography, but it's pretty close to it. I can thank club member Jim Schweitzer for some EV scope pictures that we'll have here. He images from the suburbs, so his sky isn't the best, but as you can see, there's a nice picture of M42. So we were looking at the Orion Nebula earlier with the smartphone, the DSLR, and now here's one with the EV scope at about 3 minutes of exposure. There's Stellina as well. And then there's the Revolution Imager. I was thinking of doing a little bit more on that, but everyone I've talked to, it's a funky system where it allows you to do a lot of live viewing, but the image capturing the DVR program is still a finicky process. That may take some time, but again, it's things that you may want to think about when it comes to setups, because if you're looking at adding a DSLR and a telescope and a mount, adding up those costs may actually equal some of these electronic telescopes. They're going to be a little different because you're seeing the electronic image versus the visual image, but from a suburban home, you get to see some pretty good views. So I did want to include those just to give an idea of what kind of alternatives there are. So what will work for you? It comes back down to where your imaging is. If you're looking at trying to get images of planets, you're going to have to think about what that size will be and what that imager is. What do you want to buy? What do you want to have? What is your investment plan in it? What do you already own? Are you a visual observer and you're looking at maybe trying your hand at this? Well, then that might depend on some of the things you might want to spend. Do you want to do deep sky astrophotography, but you have a Nexstar system like I do, one arm, where it's not equatorial, so you wouldn't have the smooth motion, you'll have the stepper motion. So that's going to limit how long your exposure time will be before the image gets distorted. When I first started thinking about astrophotography, I thought it would be like, I'll start with my DSLR, and maybe as I get into better at it, I might switch to an astronomical camera, CCD, and really start doing the auto guiding, the processing. I don't know. I might just be happy enough to stick with this DSLR method. I think I like what I have. Of course, my next step is to modify it to get the infrared filter out, so that way I can get some nicer pictures. Of course, I won't be able to use it now for regular pictures, but that's okay. I can find another DSLR to use for that. I have the lenses already, so I just need a body. So I might just stay with my method, and I might change after a while. It's what you want to find that will work best for you, because as I mentioned, they're not going to rival the Hubble, but there'll be images that you've taken yourself that you get to share with people. If you're doing it on a smartphone, hey, you can send it right to Facebook right away, or share it with your Facebook friends group. Have it when you take it home, you can show what you've done. It's just managing your expectations, managing what you are going to expect out of it. So that's why I wanted to show pictures that weren't really post-production modified, so that way you have a better idea of what you're going to see, so you don't get discouraged. Well, that's what I get. But those pictures can actually become that finished product with the astronomy software that they have, the stacker program, where you can stack extra images, and it's going to take out the best ones, and it will add the color and the fine detail to it. Of course, that's also a new tech side that you'll have to go through, and we'll probably have that in the fundamentals coming up, so stay tuned for that. But where do you want to go to, or who are you going to go to for the next steps? A lot of things I got were from the Observer Handbook, the Royal Astronomy Society of Canada, I guess. It has around in there, it has a chapter on astrophotography, and it talks about what you're going to need to know on a simple, like if you're taking pictures of this object, this is about the exposure time or the ISO time, and it gives you the formula. So it's showing f5 and f10 because those are common focal ratios that you find or are close to, so you have an idea on what it works. But it does talk about how you can adjust it based on the math for it. So, as we were taught in school that, you're going to need this math sometime. Well, you picked a hobby where you probably need the math. Watch or Backyard Astronomer. Those are two books that you hear a lot about when you're getting into astronomy. They do have sections about astrophotography and some of the beginning steps that you might want. So that's a good place to go. Forums like Cloudy Night's website has astrophotography website, CCD imaging. It's where you can go and share ideas, ask questions, learn a little bit from others, and then of course other astrophotographers. Hopefully, as we approach in person again at some point, there will be gatherings. There are club members that do astrophotography. They'll be approachable and talk about things. Now, and then the last couple of things is some websites. I have NASA's spacemath.gsfc.nasa.gov because you have a guide to smartphone astrophotography. It's a PDF book that you can download for free, and it will take you from the basic stuff that I was talking about to some of the more advanced, because I didn't even talk about Bayer matrix or light curves, things that you start learning about as you're taking the images. You start looking at the histograms of what you've taken so you can have a better idea of what you're imaging or how you can refine it. Those are stages that you want to pass the beginner stage. Right now at the beginner stage, you want to try and learn what tools you need, what equipment you're going to want to take, and then remember that things are attached so you don't have expensive laptops flying through the air because you're trying to save your telescope tube. So things like that is what you'll try to, or remembering to put the right memory card in, so in the middle of an eclipse you're not switching out memory cards instead of just being able to watch it. So sometimes you follow the advice that someone gives you. Your first eclipse, you should just sit back and watch. Don't worry about photos. You can do that the next time, especially when it's a 2.5 minute one. But these are the things you'll learn. One I also wanted to add is something that I'd come across. The Kalamazoo Astronomical Society, they've been sharing information with a lot of astronomy clubs. They've been doing a beginner series. They're at part 5 this Saturday, March 20th. Saturday at 1 o'clock Eastern time, I think, because Kalamazoo's in Michigan's Eastern time. They're doing the art of astrophotography. So their website is KAS, Kalamazoo Astronomical Society, online.org. You would have to register for it. It's a free seminar, Zoom, of course, but it might be something interesting to take a look at if you want to learn a little bit more, or as you keep going, because this is just the start. As you practice and learn more, you'll be able to do it. Then go back to our YouTube page for Naper Astro, so youtube.com/Naper Astro, and we've had our astrophotography basics to middle program from December 15th. Chris Almanza did that program back in December. Kind of some of the things I talked about, he had also talked about. I mean, I think there's pretty similar when we're going with it. His went a little bit further into the processing side, so you can build off of what I did here with Chris's presentation. So it's on NAA YouTube site, December 15th. Take a look at that as well. And Tony Morales gave me some pictures of smartphone with the DOB. One of the things we always hear about is you got a DOB, you can't do astrophotography with that. I mean, unless you had a tracking mount, you might be able to. But this was with the iPhone 7 and the Zoom L 10-inch DOB. And it works great with bright objects like the moon. He did the blood moon, and then of course just another moon at the face, but you still get some very nice picture, and you can look at the craters and the Terminator line. You can see some of the ridges, the mountains, so you still get some nice features just by doing that afocal. So regardless of what equipment you have, there's a good opportunity for you to start if you're interested. And even with the basic and basic equipment, you can start getting a little bit better idea on what to do picture wise, and you can go from there. Now, I wanted to talk a little bit more about imaging. These are just going to be some comparisons. So I put together all of the Orion Nebula pictures that I had used. The smartphone one up here, again, it was done with 3 seconds exposure time, so held up to the eyepiece. I think the eyepiece was 13 millimeter, so it was pretty nice magnification on my 8 SCT. Probably looking at trying to do the math, about 80 or so magnification. You see some of the coloring. What's nice about this is, just for the visual person that I am, this was done with prime focus DSLR. If you look at the train of stars, this went this way. On here, it's the mirror image because I had a diagonal. So I was doing afocal eyepiece diagonal, so I had a mirror image of what's down here. It's just something funny that I had noticed, but I figured I'll be nerdy and share it. But you can still see this was 15 seconds now. It's not magnified because it was prime focus, so that means I did no magnification. It was just the DSLR attached to the 8-inch SCT with the 6.3 focal reducer. So I got the millimeter. It was down to, well, actually the same length, because that one I also had the 6.3 focal reducer on for the eyepiece as well when I was doing these. Here is a picture that was done with the EV scope that Jim had provided. 3-minute exposure time, but you can start seeing all the colors. This had no filters on there. Remember how I was talking about the CCD large format cameras with the monochrome where you might do filters so you get different layers? Jim had provided one with the oxygen 3 filter. So this is just taking out that narrow band of light that's coming at that level. So you can see it's a different color. But what you would do then is, if you put the next filter in, you would be able to build the layers that are here, as I'm pointing with my hand instead of the mouse pointer. But that's how you build on when you're doing the CCD with different filters. So there's some different options, but this gives you a little bit of an idea. Now let's compare image sizes. So remember how I was talking about the planets being small and the field of view, and the moon? Here's the moon. That's that half degree that I was talking about, 30 arc minutes. Here's Mars. Mars at 22 arc seconds. Basically, this was done in September. I believe the picture is September 28th. So this was probably done near opposition. So you're probably at that 22 arc seconds, which is 6/1000th of a degree versus a half a degree. So even with the EV scope, Jim was telling me it's not the best for planets. And of course we can see because of the field of view, but I thanked them for this because I wanted to show how equipment is going to make a difference on when you're doing your choice of imaging. If you're going to be doing solar system imaging, you're going to want a solar system imager or a webcam that may have been modified, so that way you can use a Barlow or something to make this image bigger so we can see a little bit more detail. Because even though Mars is pretty big, it's pretty close, but it still has a small angular size for us, so it's not going to be big. So you know what? You're probably thinking, well, that's just a small picture. Well, if I still enlarged it, it's still small Mars. So even if you try and get it bigger, you're going to see a little bit more detail on it, but you really do need to. And that's really what's going to happen when you take an image, like I've taken pictures with my DSLR, or even with Jupiter or Saturn, and they're still going to come out small because of the field of view that the picture allows. And you want to make sure when you're going into imaging to know what that expectation is, to know what you're going to get back. So that way you can learn and build on and make sure you're using the right equipment choices for it. So that way you do have a more enjoyable experience on it. And that way you can continue to progress in the hobby and get that intended picture that you were looking at. So that wraps up my intro to kind of an overview of the different methods you can use for taking astrophotography and kind of what that end result will be. See, Jim, if there's any questions.
Yeah, we got one question. This might be kind of difficult to answer because I'm sure it depends on your setup. But Dave asks, in a dark sky, what ISO and exposure would get you a good image of the Milky Way with a DSLR on a tripod? Do you have any notes of kind of what you do for a Milky Way picture?
Yeah, let me get back to it. You're really only looking at you're still looking at about starting at between 400 and 800 ISO, but it really comes down to the lens. You want to, and then you're looking at a couple of seconds, and you're going to build off of that. That's one of the things I like about taking my laptop is because especially when you're using a DSLR, when you take the image of it, it gives you a recording of what you used, what your ISO was. Because when I was building this PowerPoint up, when I was grabbing some of the pictures, I couldn't remember what I used in the field, so I was able to look at the properties and it tells me on it. I would have to pull up the one for the picture I used. My Milky Way picture was from Wyoming King State Park, Western Illinois, so it was near the Iowa border. It was just about a half hour south of Western Illinois, Macomb. Great place. I could show you. When we went there, we talked to the park ranger, and he turned off the light for inside the park by the restrooms. So that way we had a dark spot. Of course, the problem is to the south of us, there was a power tower that has a red light on it. So that way things don't fly into the tower. So I had like a big red supernova in that picture. If you go back to it, I think you can see some of the, if I didn't crop it, you'll see the tree off to the right was very red because of the reflection. I'd have to kind of look at it, but really you're only looking at something that bright. You only need, in a dark sky, you'll only need an ISO of about 400 is what I would start with. You might want to go up to 800 depending on your camera. And the exposure time is a couple of seconds. But what I want to do is I want to go back there with a prime lens, want to try it. So in May, when I'm going to be heading out, I'm going to pick up a prime lens just to get a wide angle view on my piggyback, just to get it. So I'll be able to probably share it with you, but I would start with like the 400 ISO and then do a couple of seconds, bring a laptop at a dark site, and then that way you can kind of add on to it, because the laptop will let you magnify the image. So after you've captured it, you can, if you have the live capture viewing, you can magnify the image, because that also helps you kind of get the focus going. Because I didn't even talk about the difficulty of focusing, because that's just something that takes time. But you're looking at, you don't need too much to start with, because the Milky Way and the brightness of it in a dark site, you'd be surprised at how quickly it will come through.
Okay, I think that is all the questions that we have. Thank you very much, Andy.
All right, thank you. I had a fun time.
All right. Thank you, everybody, for joining. You all have a good night.
Good night.